Hi, this is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, I want to discuss about electrostatics. In electrostatics, what is Gauss law, how its proof will be completed. Before discussing about the Gauss law statement, we want to know some basic about lines of forces. We know in school education, we discuss what is line of force. Of course, there is magnetic line of force as well as electric line of force. So, before discussing about the electric line of force, firstly, what is magnetic line of force? We know if any magnetic field, a north pole, free north pole, which move from north pole to south pole in a particular path. So, the path followed by a free north pole is called magnetic line of force. Similarly, in electrostatics, a free positive charge will move from positive charge and reach the negative charge. So, an imaginary line which is passing from positive charge to negative charge, or an imaginary line drawn in an electric field in which a free isolated positive charge moves is called an electric line of force. So, in which what is this? So, that we can define as an imaginary line drawn in an electric field along which a free isolated positive charge moves is called an electric line of force. In the diagram, this is positive charge in which electric lines will move from positive charge. In this line of forces will reach negative charge. In this diagram, we can see that the positive charge will move from positive charge to negative charge. This is called electric line of forces. So, we can draw number of line of forces between two lines. So, there is an infinite number of electric line of forces we can draw. And so, what is this electric flux? We know there is a number of line of forces we can draw in an electric field. The total number of line of forces which is passing normal to the specified surface area is called electric flux. So, in the definition of the electric flux, we cannot specify particular surface area, whatever its surface area. So, the total number of line of forces which is passing normal to the surface is called electric flux. So, the definition can be defined as the total number of electric line of forces crossing the surface in a direction normal to the surface is called an electric flux. So, how can we define the electric flux? The formula can be written as electric flux phi is equal to E into A, where E is called intensity of electric field and capital A is called area of the surface. If the area is very small particular area, that is ds, then the uh, electric flux or number of line of forces which is passing through the surface area ds can be written as d pi is equal to E into ds. So, if we require total flux, that is nothing but total flux pi is equal to, it is nothing but where d pi is equal to very small number of line of forces which is passing normal to the surface area ds only. If we require to a number of line of forces which is passing to the total surface area, we have to integrate this. So, the total electric flux pi can be written as pi is equal to integration E ds. So, before discussing about the once again Gauss law, you want to know about basic concepts, basic definitions, that is the intensity of electric field, that can be written as capital E. There is two definitions mostly for the intensity of electric field. The first definition is on the basis of number of line of forces, and the second definition is basis of force exerted on the unit positive charge. So, in the first definition, we know in the electric flux number of line of forces which is passing through area is called flux. So, number of line of electric line of forces which is passing normal to the unit surface area is called intensity of electric field. Electric flux is nothing but number of line of forces which is passing normal to the surface area. Intensity of electric field is nothing but number of line of forces which is passing normal to the unit surface area. That is difference between intensity of electric field and electric flux. So, from the definition, the intensity of electric field capital E is equal to pi by A, where pi is the total electric flux and A is the area of the surface. So, from this formula we can say that the intensity of electric field capital E is equal to number of line of forces per unit area. And second definition is that when a positive unit charge is placed in an electric field, some force experienced. So, that force experienced in an electric field by the unit positive charge is called intensity of electric field. So, that is the force experienced by unit positive charge. So, the intensity of electric field can be written as E is equal to F by Q, force per unit positive charge is called intensity of electric field. So, these definitions are most useful for us in explaining the Gauss law. So, one more formula we can write for the intensity of electric field by using the Coulomb inverse square law. We know from the school education also onwards what is Coulomb inverse square law. The force of attraction or force of repulsion between two charges is directly proportional to product of the two charges and inversely proportional to square of the distance between them. So, what force is there? We know from school education onwards, we know there is attractive force between different charges. That is, there is force of attraction between positive charge and negative charge, or there is repulsive force between alike charges. Between there is two positive charges, there is repulsive force, and there is two negative charges, there is also repulsive force. So, the magnitude of this reflective force or maybe attractive force can be calculated by using the Newton's this Coulomb's inverse square law. So, according to the Coulomb inverse square law, the force of attraction or repulsion between two point charges F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. When the electric field, now how can we write? The intensity of electric field E is equal to F is equal to 1 by 4 pi epsilon into Q by R, Q1 Q2 by R square by charge Q. So, when one charge is cancel each other, the intensity of electric field E can be written as 1 by 4 pi epsilon naught into Q by R square. So, these are the main formulas for intensity of electric field. Now, we will define what is Gauss law. So, we know electric flux is nothing but total number of lines of force which is passing normal to the surface, that is electric flux. This electric flux enclosed by the closed surface is equal to 1 by epsilon naught times of total charge enclosed within the surface. So, for example, here we will see the diagram. So, this is the closed surface. Maybe the shape is whatever it is, maybe it is spherical, maybe it is ellipsoidal, maybe it is cylindrical, what shape it is, in which some charge is there, Q charge is placed at the center inside of the object, here is there. Now, when the charge is inside of the closed surface, the total electric flux pi is equal to 1 by epsilon naught times of Q 1 by epsilon naught times of total charge within the closed surface, that is right, where flux pi is equal to 1 by epsilon naught times of Q, where Q is the total charge inside of the closed surface. So, how can we define this? So, Gauss law states that total number of electric line of force or total normal electric flux over a closed surface is equal to 1 by epsilon naught times total charge Q enclosed within the surface. So, we know the flux pi is equal to integration E dot ds. So, E dot ds can be written as E ds cos theta, because E dot ds, that is A bar dot B bar, is equal to A B cos theta. Accordingly, if theta is the angle between E and ds, phi is equal to integration E ds cos theta, that is equal to 1 by epsilon naught into q according to Gauss law. How can we prove this? Because there is two types of proofs we can see. One is when the charge is within the closed surface, and the second case is when the charge is outside the closed surface. So, in the first case, when the charge is within the closed surface, for example, here there is yellow color, there is an object, there is a closed surface, at O there is a point charge q. Now, this that is the point of charge q, from which the lines of forces will move in all directions. One of the line of forces which is moving along OP, that is the intensity of electric field, is also along that direction, and different electric line of forces which is passing along the different directions. Now, where ds is the some surface area we observed, where ds is the normal drawn to the surface area, and theta is the angle between E and ds. So, what is ds? ds is a normal drawn to the surface area ds, and where r is the distance between point O and point P, where P is the a point on the surface of the surface of the enclosed object. Now, so this is the explanation. Let a charge q is placed at a point O within a closed surface of a regular shape as shown in figure. Consider a point P on the surface at a distance r from point O. Now, assume small area around P is ds. Now, I draw a normal ds along this direction. Now, normal along this direction, and represented by a vector ds, and makes an angle theta with the direction of electric field E along OP. Now, number of line of forces, how many number of line of forces which is passing normal to the surface area ds, what I required. This is we know. This is along to how many number of line of forces which is passing normal to the surface area ds. So, that is equal to d pi is equal to E into ds, because E is the intensity of electric field, ds is the area. So, the d pi is equal to E dot ds according to the electric flux definition. We know the angle between E and ds is theta. So, that d pi is equal to E ds cos theta, that is taken as equation 1. Now, but the according to the Coulomb's universe square law, the intensity of electric field capital E is equal to 1 by 4 pi epsilon naught into Q1 Q2 by Q by R square. Already we discussed in the previous slide. Intensity of electric field E is equal to 1 by 4 pi epsilon naught into Q by R square. When we substitute this E value into the above equation, the flux d pi is equal to 1 by 4 pi epsilon naught into Q by R square ds cos theta. So, thus ds cos theta by R square I wrote it differently. This is ds cos theta by R square, that is equal to solid angle d omega. It is subtended by area ds at center O. So, the d omega is equal to ds cos theta by R square. So, we know at intermediate level there is two angles we studied. One is a plane angle, second one is a solid angle. So, plane angle is nothing but in a two-dimensional plane, the angle between two lines is called plane angle. So, what is solid angle? Solid angle is belongs to three-dimensional. So, the solid angle subtended by area ds at some origin O. can be written as d omega is equal to ds cos theta by r square. So when we substitute that equation, that flux d phi is equal to q by 4 pi epsilon naught into d omega. Now what is total flux? We know if the flux which is passing through the area ds is equal to d pi is equal to eds. The total flux we can get by integrating the above equation. Now the total flux over the whole surface area is given by pi is equal to integration of the q by 4 pi epsilon naught into d omega. So that pi is equal to q by 4 pi epsilon naught into integration d omega. What is integration d omega? Total solid angle at the point O. So how much is the total solid angle by the closed surface at point O? That is equal to 4 pi. How it is? We know at a plane angle, the angle subtended at center O is 360 degrees. That is equal to 2 pi radian, we know. At the same time, the solid angle subtended at the center of the point O by the closed surface is 4 pi steradian. So the integration d omega can be written as 4 pi. Now the total flux pi is equal to q pi 4 pi epsilon naught into d pi, where d pi is equal 4 pi. 4 pi is equal to integration d omega. Now the total flux pi is equal to q by epsilon naught, because this 4 pi and this 4 pi are cancelled each other. So the total flux pi is equal to q by epsilon naught. So from this equation, what can we say? The total flux pi is equal to 1 by epsilon naught times of total charge q enclosed by the surface. So this is called Gauss law. So the total number of electric lines of force or total flux over a closed surface is 1 by epsilon naught times the total charge q enclosed within the surface. This is called Gauss law. If there is not a single charge q, there is number of charges are there inside of the closed surface, then what happens? For example, this is some closed surface. This is one charge is here, one more charge q2 is here, one more charge q3 is here, one more charge q4 here, one more charge q5 here. Then how can? So the total charge q is equal to algebraic sum of all these charges. That is, total charge q is equal to q1 plus q2 plus q3 plus q4 and so on. So when apply that, total flux pi is equal to q1 plus q2 plus q3 plus q4 plus and so on by epsilon naught. This is also another form of the Gauss law. If there is any charge inside of the closed surface is minus, then we can write, for example, q2 is minus q2, then the total flux pi is equal to q1 minus q2 plus q3 plus q4 and so on by epsilon naught. This is the actually Gauss law when object is inside of the closed surface, charge is inside of the closed surface. And what about the second case? When the charge is outside of the closed surface, then what happens? Now we will discuss this. So this is one closed surface, okay, whatever it is shape. Now there is some charge is q is there outside of this closed surface. Now what is the moment of the electric line of forces? Now we will see here. The line of forces will move outside to the through it and is passing through the closed surface. Of course, it's around the charge will move. Now I am assuming only two line of forces which is passing through the closed surface along direction PQRS. Now, so there is a line of forces which is passing along P, along Q, along R and along S, along different areas, that is maybe ds1 at P, ds2 at Q, ds3 at R, ds4 at S. But at P, the line of forces which is passing inside of the closed surface. At Q, line of forces which is coming from the closed surface. At R, the line of forces which is entering into the closed surface. At S, line of forces which is coming from the closed surface. So, the electric flux P through the area ds1 is equal to, electric flux is nothing but number of line of forces, q by 4 pi epsilon naught into d omega according to the previous line. Now, next, electric line of forces q through area ds2 is how much? Here, that is equal to plus q by 4 pi epsilon naught into d omega, because at ds1 line of forces entering into the closed surface, that is taken as minus. Now at the ds2 the line of forces is leaving from the closed surface, so it is taken as plus. What about r? There is also number of line of forces is entering into the closed surface, so again it is minus. And at the fourth place, at S, the electric flux at S through ds4 is plus q by 4 pi epsilon naught into d omega, because the line of forces is coming from the closed surface. Now, what is the total flux? The total flux is equal to sum of the all these four, minus q by 4 pi epsilon into d omega plus q by 4 pi epsilon d omega minus q by 4 pi epsilon d omega plus q by 4 pi epsilon d omega. So, this and this is cancelled, this and this is cancelled, the total is equal to 0. So, the total electric flux is equal to 0 when the charge is outside of the closed surface. So, the total electric flux over the whole surface due to an external charge is 0. This is also verification of the Gauss law. Now, there is this up to now we have, there is integral form of the Gauss law we observe, that is E is equal to pi is equal to integration E dot ds is equal to q by epsilon, that is integration, that is called integral form of the Gauss law. Now, we will change that integral form into differential form. How can? According to the Gauss law, the total flux pi is equal to integration E dot ds, that is equal to 1 by 4 epsilon naught into q. This is a integration, so that is called integral form of the Gauss law. Wow. Total flux pi is equal to, when epsilon naught is coming towards this side, pi is epsilon naught into E dot ds, that is equal to q. But what is q? Q is the total charge. Q is the total charge within the closed surface. If rho is the charge density, we know charge density rho is equal to total charge q by volume v, or q is equal to rho into v, we know. So, charge per unit volume is called charge density. So, by using this q is equal to rho into v, but v is what is volume? Volume is nothing but, total volume is nothing but integration dv you can write. So, the total charge q is equal to volume integration of the rho dv. Rho is the charge density, volume integration of dv is nothing but total volume. When we substitute this q value into the above equation, total flux pi is equal to epsilon naught into integration ds is equal to volume integration of the rho dot dv. In the left side there is a surface integration, at the right side there is a volume integration. So, I want to convert from volume integration to surface integration, or either surface integration to volume integration. We know at a degree first year we know Gauss divergence theorem. By using Gauss divergence theorem, we can convert from surface integration to volume integration, or volume integration to surface integration. According to the Gauss divergence law or Gauss divergence theorem, integration E dot ds is equal to volume integration of the del dot E dv or div dv, divergence of the E dv, or that also called del dot E dv. So when we substitute this value into the above equation, from equations 3 and 4. So epsilon naught into value integration of del dot E dV is equal to value integration of rho dV. So both of them are value integration, that is valid. So epsilon naught into, when coming this right side, value integration of del dot E dV is equal to dV dV is equal to value integration of rho by epsilon naught dV. So this equation is true at any arbitrary value, hence integration integrands must be cancelled. So del dot E is equal to rho by epsilon naught. So del dot E, del is divergence E, del is nothing but we know I into dou by dou x plus j into dou by dou y plus k into dou by dou z. There is differentiation. So this is called differential form of the Gauss law. Of course, other forms we have this we know del d is displacement d is equal to epsilon naught E, and hence del dot d is equal to rho. This is also another form of the Gauss law in differential form. So thank you. This is the about the Gauss law and its proof. Durga Prasad Ram.